Yes, recording.
Hi.
Oh wait, you can put photos.
That was bizarre, huh? The microphone? Yeah. It's pretty sensitive. Okay, number 8. The answer is C. This is the only histogram that is single-peaked and symmetric. And if you don't know, a normal distribution looks like by now.
Whoa. That's
remember the middle finger.
Yes. That's exactly the way I remember it.
Really?
You know we should write at the end of the sentence.
Number 9.
Because it's not even if you go jellyfish.
Normal, it has to look like the middle finger. No, that's hot. Number 9. No. 9. Da. Okay, so the best male long jumpers since 1973 have averaged 263 with a standard deviation of 14. The best female long jumpers have averaged 201.2 with a standard deviation of 7.7. This year, Joey jumped 275 and his sister Carla jumped 207. Both of them are from State College. Assuming that this is all normally distributed, which I'm sure it's not, within their groups, which athlete was more impressive? So this is asking you to normalize. Normalize and compare z-scores.
Whichever one's higher is the better.
That's right. So the first one, we'll do Joey's first. So Joey has a z-score equal to his jump, which was 275. What?
It smelled really good. We didn't know what it was.
Just randomly.
Oh, it's a sprayer.
Oh, is that the one that it detects motion but it doesn't spray every time?
Yeah, it comes randomly.
I don't remember what it is.
Wait, but that's different.
I think it's like Hawaiian something or other. Yeah. We're all, yeah. Minus 263, which is the mean, divided by a standard deviation of 14. That gives Joey a standardized score of 0.87. 857. Erase. 57. And then Carla.
Isn't z-scores only supposed to be 2 decimal points?
Yeah.
So it's 6.
Oh, yeah. Carla's z-score, she jumped 207. And the average female jump was 201.2. Divided by the z-score for female jumpers. Giving Carla a z-score of 75? So Joey So Joey performs better against his group. Okay.
Why? Give a brief explanation.
Maybe we should stick with this. Joey jumps better.
So if you just write that, that's not enough.
No, I'm just trying to. I mean, I'm hearing the Y and the Y, and we can actually answer the Y. Joey jumps better than what percent of? Let's figure that out. 0.86.
Joey's the favorite child.
Oops.
Hey. Life's a bitch. Joey.
0.86 comma 1 E99. So Joey performs better than 19%. About 19.5%. 1949.
So is the z-score not sufficient?
Oh no, I'm backwards here. Sorry. Let's do that again.
Did you do that wrong?
Yeah, I did that backwards. We want to know better than. He is better than
Yeah, I was gonna say, I'm like, that's really low.
negative 1E99. Yeah, you got it. Negative 1E99 to 0.86.
Why are you doing negative?
So he does better than 8.8051. 0.8051.
Why, or did you just do the opposite?
Yeah, I want to know what percent can he do better than? He does better than 80% of boys.
Or can't you just do 100 minus 90?
Yeah, I could have done that.
Yeah.
Carla jumps better than. Let's figure that out. That's 0.75 now.
19.
And this is just taking the assignment a little bit further. She only does better than 77.7734. What a disgrace. Hey, yeah.
I'm confused that we use the same data
Yeah?
regarding Joey and Carlos, but aren't the means and standard deviations different?
We did use difference in means.
We use different means and standard deviations
Oh, we did?
Yeah.
To find those percentages?
to find their z-scores.
Therefore, the percent.
Yeah.
Oh, okay.
The idea is once you get it to a z-score, it's the same normal curve every time.
So normalization is really just finding the z-score.
Yes.
Oh, that makes sense.
All right. Okay, so the length of pregnancies from conception to natural birth among certain female population is normally distributed with a mean of 270 and a standard deviation of 10 days. So for question 10, we have a normal distribution, 270 and 10. Shh, please. And what do we want to figure out? We want to figure out what percent of pregnancies last more than 300 days. So, first of all, we'll take that 300. And we're going to normalize that. This is 300 minus 270 divided by 10. And you know that that's 3.
Knowing that we can just go 68, 95, 97.
Okay, so if we know the probability that the pregnancy is greater than 300 days is the same thing as knowing the probability that Z is greater than 3.
On the other side.
And we calculated that already, right? 0.0015. I think that was 0.00.
0.0015.
135.
What?
Well, you could do approximately and just say use the rule.
Oh, yeah.
It's
Well,
not 1.3, it's 1.5.
go with 3.
Look on here. Look at
All right.
Look at the rules.
The rules.
Okay. All right, so now we're getting into the, are we doing approximate or are we doing exactly? Okay, so I think maybe we should do exactly now. So let's figure out exactly greater than 3. So we're going to do the probability exactly greater than 3. So from 3 to 1 E99. And that's 0013. Okay. So approximately 0.13% of births are longer than 300 days.
Does that actually happen?
Okay, Jordan.
That's 10 months.
Actually,
Is that really? Wow.
Isn't that supposed to be babies are supposed to be cooking?
are supposed to be cooking.
B.
Fine, loading.
How short must a pregnancy be in order to fall in the shortest 10% of all pregnancies? So let's take a look at that. We want the shortest 10%. So what we're saying is, here's the mean of 270. Here's one standard deviation below, which is 260. It's a negative one. And we want to know if this is 0.1. 0.1. The area is 0.1. That looks like a bad one. 0.1. So that's the lowest 10% right there. And we got to get the z-score first. So we're going to inverse norm to find the z-score. So once again, second vars, inverse norm. From my wonderful drawing, we saw that the area to the left is 0.1. I got negative 1.28. So here, that I'm going to fill this in was negative 1.28.
So we always need to put the area to
Always area to the left. Negative 1.28. And now that I have that z-score, I can use the normalization techniques to figure out what the pregnancy length is. Okay. So let's see. My z-score is negative. My z-score is negative 1.28. My x is unknown. My mean is 270, and my standard deviation is 10. 60, 58, 57.8. 257.8.
That's X?
Yeah, I think so. Solver.
2. How do you
Oh,
270 minus 12.8.
What's the solver?
257.18.
Should we practice the solver?
257.2.
Yeah.
Yeah.
257.2.
So let's practice the solver. Math. Solver.
Wait, why do we need that? Why can't we just do it ourselves?
You can do it any way you want.
Do it. Like me.
Some people are really bad at algebra.
Usually like 100%.
It's a skill. So what do we got? We have negative 1.28. minus
Wait, is it plus?
Yeah, it'd be plus.
Yeah.
plus.
Yeah.
Because you bring it over the other side. You add 1 point.
Or you're bringing the rest of it?
No, I'm bringing the left to the right.
Oh, okay.
Minus x
What do you like?
minus 270 divided by 10. I'm going the other way around. And from here, yeah, sorry.
Minus 270 and then you divide it by 10.
No, I'm out.
What do you mean?
No, 2.
Okay, and remember the way to do it is to push alpha, enter.
Oh, you just don't push enter?
Don't just push enter, push alpha,
How do you go back?
enter. Hey, didn't I say 257.2? No, I said 257.8.
Yeah.
Yeah,
Get out of here.
257.2.
How did I get 2.4?
Push green, enter. Push green, enter. Haley, you passed the AP test in calculus. What are you doing solving this with your solver?
Yeah, I'm doing this exactly.
The solver is literally
This is
all
worse
of
than me
that
actually doing it.
before this class is nullified. It's solver.
I could have passed algebra.
But I can't work this
Yeah, you
solver, so it
could've.
doesn't matter.
Really, it's all null. It's all null. I'm the only one that makes me so mad.
No, I love algebra.
I miss algebra. No, it just bothers me that it never works for me.
I just hate it.
It's not like
You're not you're pushing green, alpha, enter.
I am.
School is all null.
Algebra's the one thing I need to do if I start
Let me
using
let me see your calculator. Haley,
What's
Haley, bring it over.
Algebra's something I'm good at. If I start using solver, that would
Our
take
entire test time was calculated, right?
Come on.
Like, do you
Come
have more
on.
chicken?
Take the solver for you.
Because it bothers me that it's not working ever.
Do you have
Here.
more chicken?
Push green. Push enter. What's your
I
problem?
don't know. Your fingers feel like pressing something on the way to the enter.
Time for you to use the solver.
It just wants. It just.
Yes. Okay. No, you're doing fine. Push green. Now push enter.
Haley, what's under it to get rid of?
Okay. You have to push green enter in order to get this.
I can't. That has capabilities. You guys, I can.
You don't have to be here at 6:30.
Yeah.
So is this test just going to be a bunch of like ambiguous, like not specific questions, like number 11 and number
There'll be a few of them, yeah.
just ones that don't have information?
Conceptual.
Conceptual. And are we gonna do no drag?
I don't think so.
That is the only reason why I got to be on the test, because I had no idea what no drag was.
Okay, let's get it back together. Has everybody... Okay, everyone. Has everybody who wanted to use the solver got a chance to verify the solver working? Okay. Don't forget, now the number one problem with the solver is you forget to push alpha before you push enter. You have to push alpha enter for your
So you press enter and then you press alpha enter again. Okay.
You have to, once you get the equation in there, you have to push alpha enter in order for your calculator to solve. Okay? Now for some conceptual questions. 11. Okay, the density curve.
They found me.
Waiting for the helicopters. Okay. Now the density curve that you see here, contrary. Now this is like a trap question. Just because the density curve you see is single peak and symmetric does not mean it's a normal curve. You could probably say approximately normal, but this is not normal, exactly normal. Okay, so not every single peak symmetric curve is normal.
What defines normality?
Okay, so normal. Okay, first of all, normal curves go from positive infinity or from negative infinity to positive infinity. Okay. Also, normal curves centered at x equals 0 or z equals 0. Also, normal curves have a point of inflection at z equals -1 and z equals +1. Okay. And of course are single peaked and symmetric. Okay. Unless you can qualify on all of that, then you don't actually have a normal curve. So there's a couple problems with the curve they give you here. First of all, the peak is at 0.5. Second of all, the domain for this curve is not from negative infinity to positive infinity. Third of all, this curve has no inflection points. So really, this is not a normal curve. You can say approximately normal, but this is not normal. Okay?
So what's the answer?
So the answer here is, yeah, it's symmetric. That's the best I can do. Symmetric.
Is that the answer?
Yeah.
Can we possibly see what a normal density curve looks like?
Yeah, sure.
Wait, are we looking at it?
The points of inflections occur when z equals -1 and z equals +1. So right over here, I know that this point right here has a coordinate of +1. Over here, I know that this point of inflection has an ordinate of -1. Okay, so -1, +1. And of course, 0.
What about the area?
Yeah, the area is equal to 1.
Do we know if the area is equal to 1?
We don't.
Is that another reason why it's just not a normal?
But because they identify that as a density curve, every density curve has to have an area of 1. So if they're identifying it as a density curve, then you can assume that they mean that the area there is 1. Okay, cool. Yeah.
So relating to number 12, which you're about to get to,
Mm-hmm.
what defines symmetry in terms of a density curve?
same.
Yeah, both sides have the same shape.
That's it?
Yeah, there's a line of symmetry.
So meaning anything with mean or median has something to do with it? Or
Well, yeah, it's a symmetric curve. So the mean and median are the same number.
okay.
Okay. So for all symmetric curves, for all symmetric density curves,
The mean and
the mean and the
the median will be
median are equal. Okay? And I suppose we should also review that for a right skewed, no, we should start with left skewed. For left skewed density curves, the mean is less than the median. For right skew density curves, the median is less than the mean. Okay. And these are all properties from last chapter too. I wish its peppermint tea was more pepperminty. Pepperminty?
Go for Christmas tea. Those have a lot of them.
I only want peppermint teas because I'm feeling under the weather.
No, it's good.
Just kidding.
13.
Is there an actual different word?
Suppose that we have 16-ounce bags of chocolate chip cookies. When we make them, they calibrate the machine so that the weight of the bags have a mean of 16.1 ounces, coming out ahead by 1/10 of an ounce. Standard deviation of 0.1 ounces. So we want to know what percentage of bags will contain between 16 and 16.1 ounces. This is back to the 68, 95, 99.7 rule. No.
Wait, for the free response, do we be as descriptive as you're doing it?
I'd like you to be, yeah. We want to know, so the mean is 16.1. They tell you that. They also tell you that the standard deviation is 0.1. So 16 would be an area of, would be a z-score of -1. So this is from the 68, 99, 95, 99, 7 rule. So the probability that x is between 16 and 16.1, that's going to be equal to the probability that we have a z-score between -1 and 0. That's approximately 34%.
Is the test going to be this straightforward?
Not all of it.
But these questions that are this conceptual will.
Is there a vocabulary on this test?
There isn't a one-to-one correspondence between these questions and the test.
But there's some.
0?
Okay. The vocabulary in the test, there won't be a specific vocabulary section, but you will be expected to know the vocabulary. Okay, so continuation. Approximately what percent of bags will be underweight? So 14.
So z is greater than -1. Oh wait, we forgot less than.
Oh yeah, you're right.
You won. What's the second one? Yeah, thanks.
Yeah, see that's not.
Told you. Yeah, I think.
Okay, so we want to know underweight. Guys, you're kind of driving me crazy right about now.
I have a headache.
Okay. If you have something else to do, please go ahead and do it. but do it outside the room. This is 16.1. We want to know what percentage of bags are underweight, which would mean less than 16. If we normalize that, that would be the probability that we're less than z-score of -1. So what we're saying is the probability that x is less than 16 is the same thing as saying the probability that a z is less than -1. And we know from our 68, 95, 99.7 rule that that's approximately 16%.
Why does it not mean that less than 16.1 if it's saying underweight? Because wouldn't underweight mean under the mean?
I think what they're saying is they advertise the bags as being 16 ounces.
So they just put a little more.
They put a little bit more, yeah.
There's a reason why it's in the parentheses.
Okay. 15. Okay, and for 15, I'd like you to look at it like this. Let's take this normal distribution that we have here. Okay, and can I squish this? I don't know if I can. Yeah, no, that just makes it bigger and smaller. Let's do this in, I think I can do it in Word though. I don't want to pull out Photoshop if I don't have to. Okay, so here's the idea. And if I have a normal curve that is less spread out, okay? Let's take these two. Okay, and zoom out so we can see them both. Okay. If I take this and I squish it together so that, or no, let's take it and expand it. Okay. If I take it and expand it so that it has more spread, what should happen, and is not happening here, is the curve should get shorter to preserve the area. So think about like taking something and like squishing it together, it'll get taller, right? And if you pull it apart, it'll get shorter. Okay. Yeah, because well, it's kind of like conservation of matter because the area underneath the curve has to stay 1. So if you squish it together, it has to get taller in order to have an area of 1. And if you expand it, then the curve has to get shorter because the area has to be 1 still.
But are we ever dealing with the height of it?
In sometimes, not in this case. So if we take a look at the question here, we're saying that population 1 and population 2 have the same mean, but population 1 has a standard deviation that is twice that of population 2. In other words, population 1 is more spread out than population 2. What number is this?
15.
15. So we're saying population 1, pop 1 is more spread out than population 2. As a consequence, since we're spreading out our curve, we have to make our curve shorter. As a consequence of the area,
Wait, so you're saying the answer is B then?
hold on, the curve, the density curve for population 1 must be shorter. Okay? Must be shorter. than the density curve for pop 2. Okay. So let's see. There is no way of knowing how many observations based on mean and standard deviation. Okay. So the answer, let's see. Population 1 has twice as many observations. We have no idea of knowing. The density curve for population 1 is taller than that for population 2. No, it should be shorter because it's more spread out. More spread out means shorter. Okay. Density curves are centered around different numbers. No. The density curve is always centered around the mean, and the means are the same. So actually none of these are correct. E.
Wait, but for population 2, if the standard deviation is twice as big, wouldn't that make population 2 wider?
No, but they're saying population 1 is double. Standard deviation of population 1 is double that of population 2.
Yes.
Okay. So the correct answer is E. None of these actually are good. Okay. Since pop 1 and pop 2 have the same mean, the mean. 16? All right. The GRE, which you will be taking in a matter of 8 years or so. No, 5 years.
Graduate.
Think the SAT, but for grad school.
Is it difficult?
It's like an SAT.
Did you take it?
Yeah.
Did you do well?
Come on, John.
I did okay, I
John,
guess.
where's PCC? John.
What?
Where's PCC?
Do you know what a GRE
Did
is?
you guys know
Yeah.
what that
Yeah.
was?
Oh, Miranda, you too? Wow.
Are you serious?
Owen's not gonna be happy about that.
Someone's getting graduated.
Whoa.
Uh-oh.
CNN news break.
Uh-oh.
What? What?
I'll tell you the CNN news break.
Did you pause it or?
British Columbia Coroner's Service Glee star Corey Monteith's death is due to heroin.
Really? Wait, what? Say that again. Newsflash knew it.
Number 17, 16.
Newsflash knew that. They just figured that out?
Excuse me, can you go?
Ruled accidental.
Sure.
That's not possible.
Accidental overdose.
Really? They're still going through it?
Okay, so we have a GRE. Range of scores are from 200 to 900. Psych department finds that its scores of applicants are normal with a mean of 544. What is that? 16. The mean is 544, and the standard deviation is 103. Okay, we want to score in the top percent. So what minimum score would we need? Top 10%. So let's take a look. We need to figure out where is this 10% right here. Okay, which means this is 90% here. The mean is 544. The standard deviation is 103. So that's 647. That's a z-score of 1. That's a z-score of 0. we need to figure out this z-score here, and then turn that z-score here.
Algebra?
So let's figure out, to start off, what is a z-score?
1.28.
And it's 1.28.
You just do that by inverse norm, right?
You would just inverse norm that. I'm going to actually do that. So inverse norm. 1.28 is a really good one to memorize.
Yeah, 90%.
90%, it's a good one to memorize.
1.2.
1.28.
Calculator.
Wait, how do you do the calculator?
So
Yeah, and the area is what?
676.
So 1.98 or 1.28 here. So we got a z-score of 1.28. And we got to do the same thing. That z-score is going to be equal to that GRE score minus the mean GRE score divided by the standard deviation. So 1.28 has to be equal to our GRE score minus the mean of 544 divided by a standard deviation of 103. And oh goody, I get to use the solver again.
Yay.
Math, solver,
How do you clear solver?
scroll up and push clear.
Crazy stuff. Wait, when it gives you like 10%, is there a way to use algebra to figure that out instead of using inverse norm?
No, you have to inverse norm it. Good question.
What was this question?
X, oh, what did I just do?
You cleared it.
1.28 minus parenthesis X minus 544. Oh, nice, I forgot the minus sign. Divided by 103.
Yeah.
Push enter, and then push green enter.
675.
675.84. So x equals 675.84.
Wait, I got 0.988.
Okay, so this says to me that you would need. Okay, so you would need a. One needs a GRE score of 676 to be in the top 10%. Okay. GRE scores, like the SAT scores, are all whole numbers. Hmm? Yeah.
Is it a reasoning test? Like, is there something that makes it a graduate level?
I will talk about it later. Okay, set of data is normal with an upper decile of 45 and a lower decile of 17. What is the mean and standard deviation? Ooh, goody, goody, goody. Okay, so 17. We have a, this is actually probably one of the more difficult questions here. We have an upper decile and a lower decile given to us. The lower decile was 17. The upper decile was 45. And remember, a decile means 10% area.
That's two standard deviations.
Not exactly. 1.28.
Wait, I thought it was combined.
0.10, 0.10, 10%. So from the exercise we just figured out, this is 1.28 here,
So it's negative 1.
and that's negative 1.28. You could go ahead and do the inverse norm, but you know, we've done this. And we're supposed to figure out the mean and standard deviation. And unfortunately, there's no really quick algebraic way of doing this on your calculator. So we'll just write out our equations right now. So the first one, negative 1.28 is equal to our 17, which is our measurement, minus our mean divided by standard deviation. And we also know 1.28 is equal to 45 minus the mean divided by the standard deviation. And we need to figure all of this out. So first step, let's turn these into linear equations. Negative 1.28 sigma equals 17 minus mu. 1.28 sigma equals 45 minus mu.
So from here on it's just algebra.
So now it's algebra, yeah. So we have a mu minus 1.28 is equal to 1.28 sigma equals 17. Mu plus 1.28 sigma equals 45. And now you're going to algebra this.
The algebra is so hard.
Mu plus 1.28 sigma equals 45. Hey, we can just add these two together and get rid of sigma. So we have 2 times mu is equal to 5762. And therefore mu is equal to 31. Okay? And if mu is equal to 31, that means that 31 minus 1.28 sigma equals 17. Negative 1.28 sigma equals 10, 11, 14, negative 14. And sigma, did you say 10.9?
10.9.
10.9.
How, to what decimal place do you want us to put for standard deviation?
If it's an in-depth problem, give me 4 significant figures.
So it'd be 9.4.
9.4.
Ever get fucked off for putting too many pieces in the figure?
If it's a z-score,
You really get it?
that's really my text term.
Vegetable juice?
Yep. Po people. Give me 1 second, okay? So we have normal, mean of 31, standard deviation of 10.94. Done. We're not done. We have 18.
And 19.
And 19.
18 for Joe.
Yeah.
So how would you know, how would you find the z-score to be 1.28 if you didn't do the previous problem?
Nor or inverse norm.
So you would inverse norm to like, what is it, 7?
Inverse norm to 0.1 for the lower decile. Inverse norm of 0.9 for the upper decile.
It helps if you draw the normal curve.
Yeah. Really draw the normal curve. I can't emphasize that enough. If you think it's extra, or if it's something you don't need to do, you're wrong. It really helps out your reasoning to see the curve. Like, super helps your reasoning to see that curve. No, I'm not going to judge your curve. Okay, I might laugh at them like behind closed doors, but
Towards the end of time, it's
no, I'm not good. No. Are you kidding? I draw horrible curves. 18. Suppose the scores on a test are normal with a mean and a standard deviation of 82 and 12. What are the median Q1 and Q3 scores of the test? Okay, well I can tell you the median already. It's 82. Okay, so
Is there a way of proving that?
we have a normal curve with a mean of 82, standard deviation of 12. Since since the curve is symmetric, since curve is symmetric, the mean is equal to the median, which equals 82. Great, that's half credit. Okay. Let's get those Q1s and Q3s. I'm going to draw the normal curve. I'm going to practice what I'm saying to you. I'm going to draw that normal curve. And
Would you need to draw it to get credit for it?
not necessarily.
Like for this one, since this one's just add 12.
Not necessarily. All right, so I need a 25% and I need a on the edges. So let's just pretend that. Why did you freeze? Why are you frozen? Don't. What? Why are you
Don't crap out on the edge.
so close to finishing this? What happened?
Is it plugged in?
Yeah.
Obviously, the computer doesn't want to do math.
Why did you decide to crap out?
It doesn't want to do math anymore for Ariel.
That's not an excuse. You should know whose computer it belongs to.
Who's your dad?
Let's try it again. Unplug. Replug.
Did you try turning it on and then
Oh, it just stopped working.
Yeah. You know what? Maybe I need to close this.
Oh, yeah.
Okay. So we have 25% area. That's Q3. Okay. And this right here, 25% area, that's I'm sorry, this is Q1 and this is Q3. Okay. So for Q1, z-score for Q1 is going to be equal to the inverse norm of 0.25. And I think that's negative 0.68.
6, 7, 6, 8. 6, 7.
0.674.
and then you just have to apply that to the
And then the z-score for Q3
The inverse.
is equal to the inverse norm of 0.75 this time. And that's equal to positive 0.67.
It's as simple as that.
Well, not quite finished yet. Okay. I'm kind of just not doing the calculator and going on memory. Yes, I memorized those. Okay, now we got to turn those into actual,
Numbers.
yeah, numbers. This is 82 right here. This has a z-score of 0. We don't know this one here, but we know that that has a z-score of negative 0.67. We know this has a z-score of positive 0.67. So we'll do negative 0.67 equals an unknown score minus the mean of 82 divided by a standard deviation of, I forgot, 12. Oh look, another chance to use solver. Negative 0.67 minus x minus 82 divided by 12, thank you. 73.96. Green, enter. 73.96.
So 74.
So Q1 equals 73.96. Then we're going to do it again. Positive 0.67 equals x minus 82 over 12. And so Q1 equals, on the calculator, scroll up,
Just get rid of that.
kill the negative, enter, green, enter,
90.04.
90, thank you, 90.04.
How exact does that have to be? 'Cause
That's Q3, not Q1.
Pretty easy.
Hmm?
like if we put 90.09 because we found the exact number, it would be marked down for us.
Well, this is the reason why I ask you to put your z-scores to 2 decimals,
So it's
just for uniformity. Okay. Okay. That's that. 19.
Is 19 an ideal FRQ?
19 looks like a great FRQ. We need to know our numbers, right?
Yeah.
All right, let's throw it into our calculator.
There's how do you do that?
Such a
Okay, I actually don't have those numbers, so can I have someone read? Anusha, you sound great. Can you read those for me?
Okay.
I was
You're not new
Here's
shit.
one, you're not new shit. Okay.
Miles asked me to.
Okay, 12.1, 10.4, 10.9.
Wait, start with these.
Oh my god. Okay. Yeah, okay. 9.1, 13.2, 11.7, 11.8, 10.7, 10.8, 12.6, 10.6, 11, 10.8, 13, 11.6, 10, 10.5, 10.1, 12.4, 11.8, 11.1, 11.7, 8.8, 11.1, 11.5.
Yeah. Okay. Nice. You know, I kind of wish I did this earlier. Went to this because the graph gave me the last graph that I was on, which was the normal probability plot. So it kind of gives you a preview of what's going on with the data. That's really cool. All right, what's question A?
Well, it's for sure.
Approximately normal.
Oh well, yeah.
What's question A?
Sure, approximately.
Question A. I don't have a thing. You have to read it. Histogram. Okay, let's do a histogram
and the 5-number summary.
and a 5-number summary. Okay, maybe we should do the 5-number summary. Get that out of the way.
Let's just not do this.
5-number summary. Stat. Calculate. 1 var statistics. I have everything in list 1. Calculate. I'm going to write down the stuff that's important. The first one is a mean, 11.17 or 11.2. So we have mean.
Wait, mean is part of the 5-number summary?
No, it's not, but I think we're going to need it eventually. The mean's 11.2. Standard deviation is 1079.
Can you write it out how it's written?
I forgot what the number was.
1.079.
Thank you.
The minimum, 8.8.
So we have a 5 num. Okay, minimum was 8.8.
Yeah, Q1 10.55.
10.55.
Medium is 11.1.
11.1.
And Q3 is 11.8. And max is 13.2.
13.2. You're welcome. See you tomorrow. That's my 5 number summary. If you write them in order, then it's going to be assumed that you put them in the increasing order from minimum to maximum.
When you look at the same, is it the SX one that you look at?
Yes.
My calculator is not showing everything. I did it before.
So how do we know again which one to use?
Why is it not showing that?
You don't have to write the standard deviation, right? Just ask for it.
Oh, you know why? You're doing list 1, comma list 1. What? Go to to the 1 bar summary again. Make sure that your frequency list is clear. Let me see.
List 1? Or list 3? Yeah.
How do we know which one to use?
It's sample.
So population's the other one, sample.
All right, our yeah.
Since it only says the 5 numbers separate, you don't have to put the standard deviation.
I'm only putting it there because I know we're gonna need it later. Okay, again, the question's only asking you for 5 number summary, so no, you did not have to write the mean and the standard deviation. However, I know that I'm gonna need those numbers later, so I'm just writing them down so I don't have to keep going back to the same screen. Okay? How do I know? What does the question ask? What's the context of these numbers?
25.
Is this a ketchup one?
Yeah.
Yeah. Is this every barrel of ketchup ever? It's not, right?
Not ketchup, catsup.
Catsup. Right. Sorry.
Part B.
Okay, we're still on part A. We're supposed to get ourselves a histogram. So, remember the easy way to do this. Go ahead, go to stat plot. Turn it on. Scroll down and change it to a histogram. You will know it's a histogram because it's a picture of a histogram. Unless you have a TI-89, in which case it says histogram. And then the correct list, the correct frequency, zoom 9. Ooh, my calculator got busted.
Yeah, mine's like that too.
Yeah, when that happens, just go quit to the home screen and then zoom 9. Oh, hey. It's giving me the middle finger. It must be a normal distribution.
Not really, because it's like. Wait, it's not giving you the middle finger.
It kind of is. Why is mine?
It's like a chubby middle finger.
Okay, remember, let me get to you in 1 second. Remember, this is not the histogram you want to draw for me because it is crazy. Okay? So you have to adjust the window. Go to window. Take the minimum, round it down. Down. Go to the max, round it up. Up. X scale, round it to the nearest integer. 1.
Oh, I got it.
Now push graph.
Wait, integer is 1?
I want to fix the Y.
I may want to fix the Y max, right?
Yeah.
Right, so back to window. Change the Y max to, let's go to 10, just for fun.
And then what do you do?
Okay, so then you push graph. Let me get to Rizwan's question. Rizwan?
Oh yeah, so how did you know to use big S instead of omega?
Sigma. I know it was a sample because I wasn't looking at the sodium content for every ketchup out there.
Oh, I thought sigma.
S is sample. Greek letters are reserved for population. Okay, let's. I'm gonna draw this by hand. So let's see. I'm gonna push trace. So I have 1, 1, 9, 9, 3, 2. Let's go to my paper and we're gonna draw that. And I'm gonna go ahead and give myself an axis. I'm gonna give myself a number line. 8, 9, 10, 11, 12, 13, 14. And the biggest one is 10, right? 9?
Yeah.
So let's go like this. That's 5. 1, 2, 3, 4. 1, 2, 3, 4. Okay, the first one was 1, right? So 1. The second one was also a 1. 1. The next one was a 9. 9. The next one is a 9. 9.
When we're drawing histogram, can we put the number on?
The next one is a 3. 3. The next one is a 2. 2. Okay, questions? Yeah, Jordan. No. You only center it if you have integer values for your list. We don't have integer values. We have numbers in between 8 and 9. We have numbers in between 9 and 10. Okay? Yeah. Except for which? Change the X min and X max. Yeah. Okay, is there anything else for part A?
No, part B now.
Part B, what's part B?
Compute the mean and standard deviation. Make a sketch of the normal probability plot.
Okay, so first thing, mean and standard deviation we already have in part A. So I'm just going to copy them down. Mean is 11.2. Standard deviation was
1.07.
okay. And let's do a sketch of our normal probability plot.
Wait, what did you use to get that?
It's the 5 number.
Yeah.
1 bar stat.
Oh, yeah.
So we don't have to do it on the test, right?
Yeah, you don't have to do anything by hand. Okay, and let's see. Okay. Let's do the same number line. 8, 10, 12, 14. Okay. And let's take a preview of our what do you call this? Normal probability plot. We'll go to our normal probability plot and zoom 9 it. Here we go. Okay, and let's just go ahead and we're going to go trace. The first one is 8.8 and -2. And the last one is 2.05. So it looks like my y-axis can go between 2 and 3. No, -2 and -3 and +3. So -3. +3. The first one is, and I'm going to do this really quick. So, what do we got? I think I can do all of them. First one is 8.8 and negative 2. 8.8 and negative 2. The next one is 9.1 and negative 1.5. So 9.1, negative 1.5. 10 and negative 1.28. 10, negative 1.28. 10 and a negative 1. 10.4 and a negative 0.9.
You really have to plot everything.
Yes, as roots.
10.5 and a negative 0.7. 10.6 and a negative 0.6. 10.7 and a negative 0.5. 10.8 and a negative 0.4. 10.8 and a negative 0.3. 10.9 and a negative 0.2. Frozen mouse. Darn it. And I'm just going to put etc. here
Will you do that?
And then we're done.
so that we don't waste our time here.
Can we do that on the
But how is it normal?
No. In the interest of time, I'm putting etc. here.
Would you ask us on a test? 'Cause it takes a lot of time.
Yes. Letter C. What's letter C?
Based on your graphical evidence, is the normal distribution an appropriate model for this data? Explain why or why not.
Okay, so our, what is it? Our histogram was approximately single-peaked and symmetric. There were no outliers. Oh, we didn't check for outliers.
Wait, can we just say it's slightly skewed?
Let's check for outliers. Real quick, check for outliers. You don't even have to compute anything.
Literally stacked all there.
We just 5 numbers on that shit.
No outliers.
No outliers. No outliers.
And see what these outliers are.
There were no outliers from our box plot. The normal probability plot was reasonably linear. Therefore, a normal distribution is appropriate.
Can you say assumed? Like if I just said
No.
that, you just have to say
No, assume means something else. It means that you have no data to support it. Thank you, everyone.
Do we have to mention the outlier part?
Yeah.
We're all gonna get
You're welcome. Have a good day. Have a good night. Of course.